Welcome back. In this lesson, we are going to implement the decision tree algorithm from scratch by 3 simple steps. But you need to know first that there is more than one implementation or one pseudocode for the decision tree. Okay? And we are going to implement one of the easiest and one of the most frequently used, which is called ID3. And ID is short for iterative dichotomizer, right? So we have 3 simple steps and we recurse or we iterate over all these steps again and again and again until we stop if we reach the stopping condition. So what are the simple steps? First, we find the best feature. So we have the full dataset or the complete dataset and we try to find the best feature. Okay. After we find the best feature, we will split the dataset based on this feature. Then, for the final step, we will partition the classes based on steps 1 and 2. So we found the best feature. And then we find the best split for this best feature. And then we partition the classes based on step 1 and step 2. Now, in order to understand these 3 steps, we are going to implement them from scratch. And we will start from step 3. Okay, this can be a little bit strange, but once we implement step 3, step 2, and step 1, and see the whole algorithm or see how we call the complete algorithm, you will understand better why we did so. Okay, so now let's implement step 3, which is partition classes. So one of the basic operations in the decision tree is to split the tree on one attribute, and this is step 1. Okay, and for step 2, we split based on a specific value. So from step 1, we get the one attribute or the best attribute, and from step 2, we get the specific value or the best value. Now, we need to also take into consideration if the split attribute is either numerical or categorical, because the decision tree can work with both numerical and categorical data at the same time. We don't really need to encode our data in order for the decision tree to work, not like the KNN. Okay, now let's see how we can implement the partition classes function. So the input for this function, this is step 3. So we already have the split attribute and we have the split value, and we just want to partition the classes. So we have X, and X is a list containing all the data attributes, and Y, which is a list of labels, and we have the split attribute corresponding to the column index of the attribute to split on, and the split value, and the split value can be either a numerical value or a categorical value, and this value should be used to divide the split attribute. Okay, now the output of the partition classes function is 4 things, right? Or 4 variables. First we have x left, then we have x right. So x left is x left after partitioning. So the left hand side of the new tree or the left hand side of this node. And then we have x right corresponding to the data on the right hand side. And then we have y left and y right corresponding to the labels of the left hand side and the labels of the right hand side. And the objective of this function is to partition the data and labels based on the split value. So before diving into the function itself or seeing how we can do this ourselves, let's see an example with numbers, right? So let's say we have these values, right? So this is X. We have this matrix or this list of lists containing 3, 1, 2, 5, 4, and then AA and so on, right? So this is the first column corresponding to the first feature, and this is the second feature, and this is the third feature. And we have how many rows? We have 5 rows. So we have 5 examples. So for the first example, the class should be 1. Okay, the label should be 1. For the second example, it's also 1. For the third example, it's 0. For the fourth example, it's 0. And for the last example, it's 1. Okay. And as we can see, columns 0 and 2 represent numerical attributes, while column 1 is a categorical attribute, right? So let's say we have the split attribute, right? The column that we are going to split based on from step 1 is the first column, right? The index for this column is 0, right? And the split value we got from step 2 is 3, right? So anything more than 3 should be in the right hand side. Anything less than or equal 3 will be in the left hand side, right? Or the other way around. It's based on your implementation or how you see the problem, okay? It should work either way. Now we divide x into two lists, right? This is what this function is doing. It's dividing x and y into two lists, right? So we are going to divide x into x left, where column 0 is less than or equal 3, and x right, where column 0 is more than 3, right? So the left hand side or the left hand tree less than or equal 3, and the right hand side will be more than 3. So as we can see here, x left is now 3, 1, and 2. And we are not going only to store these values, right? We are going to store the full example. So we are going to have the first example, the second example, and the third example in x left. Okay, and we are going to have 5 BB32, 4 CC32 in x right. So the fourth and fifth examples are going to be in x right. And accordingly, we are going to have 1, 1, 0 in y left and 0, 1 in y right. Okay, now let's consider another case where we call this function, right, the partition classes function, with a split attribute equal 1. So index 1 is basically the second column and the split value is bb, right? So in this case, in case we have a categorical variable that we are going to split based on, then we are going to divide also x into two lists, but now it's either equal this split value or not equal this split value. Okay, so as we can see here, this row and this row have bb in the second column, right? So in the left hand side, in x left, we are going to have this example and this example, and for the rest of the rows, right, we are going to have them in the right hand side, in y right, and the same for y. So this is how we can split based on a categorical or a numerical variable. And as you can notice, we are getting the split attribute and the split value from step 1 and step 2. So that's why we started by implementing this function. Okay, now how we are going to implement all this? Let's first start by making sure that x is a numpy array. So as you can see here, I'm converting x. If it was a list, then I'm converting it to a numpy array. And this is optional, you can do it or not, but I am more comfortable with working with numpy indexing. Okay, so as you can see here, y equal nb.arrayx. After that, I am going to get the column split. So we have the split attribute. So basically, from x with only the split attribute column. So this should basically return the column split. And then I am creating here x left, x right, y right, and y left, right? I'm creating 4 empty lists, and I am using or creating a variable called counter for appending. Now, as we said, we have two conditions, or we have two scenarios. Either the split value is numerical or it's categorical. So how we can make sure of this? Basically, we can have an if condition, and we have a built-in function in Python called isInstance. So we give it some variable and the class or the type for this variable, and it either returns true or false, right? Based on if this variable is actually from this class or not. So if the split value is not a string, right, it's false. So this means it's a numerical attribute. In this case, we are going to loop over all the values in the column split. So if we have 1, 2, 3, 4, 5, and we are saying that we are going to use 3, then I am going to loop over all the values. If this value is less than or equal the split value, so if it's 0, 1, 2, or 3, right? If the split value is 3, then we are going to append to the left hand side. So as you can see, x left dot append x counter, and counter is basically 0 in this step, right? And we are going to increase the counter after each iteration. So this is how we can partition the clauses. If I is less than or equal split value, then we are going to append to the left hand side. Else, so this means I is bigger than the split value, we are going to append to the right. Okay? And if we have a categorical attribute, so if this condition is not met, we are going to the else statement. So this means it's a categorical attribute. So how we are going to proceed with that? We are just going to convert less than or equal to be equal equal. So any row that contains BP, for example, in our case, will be appended to the left hand side, and anything else will be appended to the right hand side. And that's it, right? We are going to return x left, x right, y left, and y right. That's how we can implement the partition clauses function. Now, in the next lesson, we will see how we can implement the second function called find best split, and in the lesson after that, we are going to see how we can implement find best feature, and from there, we are going to see how we can implement the full algorithm, right? So let's go to the next lesson.